Good day everyone, and you're welcome once again to my YouTube channel, Master Science Guide. Now, today's lesson is for my O-level students, alright? If you're in the O-level preparing for any chemistry exam, alright? Be it nursing exam, GCSE exam, post-utme exams, any exams you are preparing for. Alright, now today's topic, we're going to be talking about stoichiometry, and basically one of the most foundational stoichiometry topic, which is known as the limiting and excess reagents. So this topic is part of stoichiometry. All right, so this is a branch of stoichiometry, limiting and excess reagent. Now, what is a limiting reagent? A limiting reagent is the reactant that is insufficient or limited. Just like the name implies, limiting reagent. So it is the reactant, all right, that is in limited supply, or that is what? Insufficient. All right. So, and it determines, please take note, it determines the amount of product formed. The limiting reagent determines the amount of product formed. Take, for example, you need to mix two substances, all right. You need to add water to rice, cooking it, water to raw rice, and in cooking it you get a full done rice that you eat. Now imagine that the water is limited, all right. You have, like, large raw rice on the pot, and you put a little water. Now by the time you set it on fire and it starts cooking, all right, because the water is small, is not enough. So what happens is that, well, the water will get finished, you discover that either the rice is half done, or it has not even be properly cooked, or it will just be prepared halfway. So in Nigeria we call it half done food. All right, so now in that case the water was limited. So the product of having a properly cooked rice, all right, was limited due to what now? The limited amount of water. So in that case, you say that the water is the limiting reagent, all right, and then the rice is the excess. The raw rice is the excess reagent. So the amount of cooked rice, the amount of full done rice you get determines on what? Determines on the water. All right, so that is it. Limiting reagent determines what? The amount of product that is formed. Then for an excess reagent, all right, an excess reagent is the reactant that is in excess or overly sufficient amount. Okay, so it is in excess or what? Overly sufficient. Now also please take note that a limiting reagent gets used up before the excess reagent. That is how it is. So a substance that is in small supply will get used up before what? The excess reagent. So once the limiting reagent gets used up, the product that will be formed, the amount of product that you will get, will be determined by the limiting. So if the limiting reagent gets used up, the product will stop forming. All right, so you are just left with the excess reagent. Now limiting and excess reagent is very similar to Gay-Lussac law in some way. All right, it is similar to Gay-Lussac law, but now let us look at practical calculation questions on limiting and excess reagents. Let's look at this question put for us on the board. It says, determine the limiting reagent when 10 gram of hydrogen reacts with 80 gram of oxygen to form water. All right, we should determine the limiting reagent when 10 gram of hydrogen reacts with 80 gram of oxygen to form water. Now, here's the solution. First and foremost, you need to write the balanced chemical equation for this reaction. So this is hydrogen, diatomic molecule, reacting with oxygen to give us what? Water. So now, to give us water. So now, let us balance the equation. How do we balance it? So you have two hydrogen here, so you have one oxygen, but two oxygen here. So put two here, hydrogen becomes 4, and then we'll put 2. So from the balanced equation, we saw that 2 mole of hydrogen, all right, react with what? 1 mole of oxygen. All right, now we're giving the values in mass, gram, right? Gram. So determine the limiting reagent. So these are how we determine the limiting reagent. Now you can decide to work with mole by converting these grams to mole. Then you can decide to work with grams, any of the directions. Some people will convert to mole, others will work with gram. So me, I can do any of them. But let's just work with the grams. Let's work with grams. Now, this is, remember, hydrogen is a diatomic molecule. So hydrogen being a diatomic molecule is H2. So that means the molecular mass for hydrogen is what? 2 times 1, which is equal to what? 2 gram per mole. Now, please take note. Please take note. Take note that we want to get the mass of hydrogen here that reacted with oxygen. All right. So the mass of 2 mole of hydrogen, the mass of 2 mole of hydrogen, we'll now say 2 times the molecular mass, which is 2. So 2 times 2 becomes what? 4. So we have gotten the mass. How am I sure about this? Use this formula. N is equal to mass over molar mass. So the mole is what? 2. The molecular mass is 2. So if you cross multiply, what will you get? Mass is equal to what? Mole times molecular mass. So that is exactly what I did here, and I got what? 4 gram. So now what we can now say is that 4 gram of hydrogen, 4 gram of hydrogen, all right, completely reacted with. Now, how do we get the mass of 1 mole of oxygen? Now, 1 mole, the mass of 1 mole of a substance is equivalent to the molecular mass of that substance. From this, now this is 1 mole, all right, nothing is just 1 mole of oxygen. So it becomes, remember, let's just use this formula to get the mass. To get the mass, it becomes N, which is 1 times, what's the molecular mass of oxygen? Oxygen, O2, is diatomic. So it's like you're saying 16 times 2, which will give us what? 32 gram. So 1 times 32 is equal to what? 32 gram. Are you seeing it? So here is gram per mole because the molecular mass, that's the unit for molecular mass. Alright? So the way you now say 1, the number of mole is 1 times the molecular mass, we still get 32. So that's gram. So 4 gram of hydrogen reacted with 32 gram of oxygen. Therefore, now listen, they said determine the limiting reagent when 10 gram of hydrogen reacts with 18 gram of oxygen. So now let us assume that we do not know the mass of oxygen. Let us assume that we do not know the mass of oxygen, that want to look for the mass of oxygen. So now let's try to get the mass of oxygen that will completely react with 10 gram of hydrogen. So therefore 10 gram of hydrogen will be reacted with x gram of oxygen. So by the time we cross multiply, what do we have? 4 times x is what? 4x equals to what? 32 times 10. 32 times 10 will give us what? So we have 4x is equal to 320. So now at this point, what do we do? Divide both sides by 4. 4 cancel out 4. Therefore, our x is equal to, now let's quickly put this in our calculator. Let's do this with our calculator. All right. So 320 divided by 4. What do we get? We got what now? 80 gram. So now it therefore means that 80 gram of oxygen is supposed to react with what? 10 gram of hydrogen. All right, 80 gram of oxygen is supposed to react with what? 10 gram of oxygen. Now, how many grams of 80 gram of oxygen is supposed to react with what? 10 gram of hydrogen. But now, how many gram of oxygen did they give me in the question? 18. But from calculations, it's supposed to be 80 gram to react with 10 gram. But in the question, we're giving what? 18 gram of oxygen. Therefore, we can now say, therefore, that oxygen is the limiting what now? Reagent. The limiting reagent. So therefore, oxygen is what? The limiting reagent. And hydrogen is the excess reagent. Thank you. Now let's look at another question. All right, to also help us further. Now let's look at this next question on the board. It says, what is the amount in gram of water produced when 5 gram of hydrogen and 5 gram of oxygen reacted together? The equation of the reaction is, so now we are already given the balanced chemical equation of the reaction. So it's very easy. Let's go. Now let us go. Now this is, now first and foremost, we have to look for what? The amount in gram of water. So the mass of water produced. Now to know the mass of water produced, we need to know the limiting reagent. To know the mass of water produced, we need to know the limiting reagent. Now let us find out the limiting reagent. Now this is how we find out the limiting reagent. Remember, limiting or excess reagent can only be at the reactant. So limiting and excess reagent, both of them, they are reactants. All right. Now this is 2 mole of hydrogen. In our previous question, we saw the conversion of 2 mole of hydrogen to gram, to mass. And what did we get? We got what? 4 gram. So now 4 gram of hydrogen reacted with what? 32 gram of oxygen. Now, from the question, 5 gram of hydrogen we react with. Now let's assume that we do not know the mass of oxygen. So let us find what mass in gram it will take oxygen to react with 5 gram of hydrogen. So let's do this. Now cross multiply. We're going to get what? We're going to get 4x is equal to 32 times 5. So 32 times 5, that will give us, so we have 32 times 5, that will give us 5 and 2 10. So put down 0, carry 1, times 3, what now? 15 plus 1, 16. So we'll get 160. Right? We're going to get 160. Then we have what? 4x. So at this point, what do? We divide both sides by 4. We're going to divide both sides by 4. Sorry. So we have 4. So 4 cancel out 4. Therefore, x is equal to 160 divided by 4. Alright, we're going to get what? 40 gram. So it therefore means that 5 gram of hydrogen is going to require what? 40 gram of oxygen. But then in the question we're provided with what? 5 gram of oxygen. From our answer, it therefore means that therefore oxygen is the limiting reagent. It is a limiting reagent. So now that we know that oxygen is a limiting reagent, now we are going to compare oxygen. Remember, a limiting reagent determines what? The amount of product that is formed. So we are going to compare the limiting reagent with what? Now the amount of water that will be formed. So now from the balanced equation, we know that 1 mole of oxygen is what? 32 gram, right, in mass. So 32 gram of oxygen we produce. Now, what are the molecular mass of water? Water is H2O. That is, hydrogen is 1, so 1 times 2 plus 16. 1 times 2 is 2. 2 plus 16, that will give us what? 18. So, it therefore means, that is, the molecular mass of water is what? 18. But now you have 2 more. Alright? 2 more. So, remember, now get the mass of water, number of moles. 2 times 18. I gave this formula in the previous question we solved. So what are we going to get? We're going to get what? 36. All right. So 32 gram of oxygen produces what? 36 gram of water. Therefore, 5 gram in the question, 5 gram of oxygen will produce how many gram of water? So we are going to cross multiply. So we therefore now have 32x equals what? 5 times 36. All right. So 5 times 36, what is it going to give us? 5 times 36 is going to give us 5 times 36. That will be 180. So we're going to have 180. So yes, 32x divide both side by what? 32 divide both side by 32. So 32 cancel out 32. Therefore, our x is equal to 180 divided 32. That is 5.6 gram of H2O that will be formed. So the mass of water that will be formed is what? 5.6 gram of water. Now, let us go into the last example question I'm going to use to show you guys. So I believe you are getting it, right? So if you are getting this, please do well to subscribe, like, and share this video to your friends. Drop a comment on what you think about this video. Let's go to the last question. Now, this is the last question we're going to be looking at in today's video. Now, this question is one of the most tricky questions you can ever come across in this topic. All right, students often find this question challenging. So that's the essence of this video. So please do it to share with your friends. All right, so now let us tackle this. It is very, very easy. First and foremost, all right, the question says calculate the number of moles of CO2. So we are looking for number of molecules rather. Calculate the number of molecules of CO2. So we are looking for the molecules of CO2 that will be produced when 10 gram of cacoteri is treated with 100 centimeter cube of 0.0 mole per dm cube HCl. So now what we are going to do is that we want to find the limiting reagent between cacoteri and HCl. Now to do this, cacoteri, all right, please bear in mind that calcium, the atomic mass 40, hydrogen is 1, Cl is 35, Cl is equal to 35.5, and then we have C equal to 12, that's carbon, and lastly oxygen is what? 16. Okay, so now let us tackle this question. Quickly, let us get the number of moles. All right, let's get the number of moles, or we can even use mass. All right, we can use mass. Okay, we can use the mass. Now let us use the mass. 1 mole. Now this is shortcut. This is already a balanced equation. Now this guy is already 1 mole of cacoteri. Now 1 mole of a substance, I repeat, the mass of 1 mole of a substance. To get the mass of 1 mole of a substance, all right, that mass is equivalent to the molecular mass of that substance. If you look at cacoteri, if you want to get the molecular mass, that's CaCO3, that will be 40 plus 12 plus 16 times 3. When you do all of this mathematically, you're going to get what? 100 gram per mole. So because we have 1 mole of cacoteri, remember to get the mass is equal to what? Mole times what? Molecular mass. And the mole 1, nothing means 1, so 1 times 100, that is what? 100 gram. Therefore the mass is what? 100 gram. So now 100 grams, we have gotten this guy. Now the mass of this is what? 100. So we have mass of cacoteri, mass of CaCO3 is what? 100 gram. Now let us get the mass of HCl, 2 moles of HCl. Now HCl is hydrogen plus chlorine. That's 1 plus 35.5, which is equal to what? 36.5. All right. So the molecular mass is what? 36.5. That's what we just got. All right. But now we have what? 2 moles. All right. So it now becomes 36.5. You know, now mass N times molecular mass. So like you're saying 36.5. All right, let's assume this. So 36.5, sorry, number of moles is 2 times 36.5. And when we do that, we're going to get 2 times 36.5. We're going to get what? 73. So the mass is what? 73 gram. So mass of ACl is what? 73 gram. All right. Now, let's now go into it in proper. Now look at this. Look at this. CaCO3. Now, 1 mole of CaCO3 is 100 grams. So from the balanced equation, 100 gram of cacotyl reacted with what? 73 gram. 73 gram of what now? 2 moles of ACl. That is ACl. Therefore, 10 gram of cacotyl we react with. Now, here comes a tricky aspect. We want to get, let's resolve this, 100 centimeter cube of 0.2 molar ACl. Now, this is what we are going to do. This is what we are going to do. Remember a formula in stoichiometry which says that N number of moles is equal to CV, right? Volume is centimeter cube all over 1000. Now let's use this to get the number of moles of ACl in the question. All right, so N is equal to, the concentration is what? 0.2 times the volume is what? 100 divided by what? 1000 rather. So 0.2 times 100 is 20 divided by 1000. We're going to get what? 0.02 mole. 0.02 mole. All right, now can you get this? Now let us convert this mole. Remember, everything we are working here with is what? Mass. Everything we are working here with is what? The mass. Now let us convert this 0.02 mole to mass. Pardon? So let us convert 0.02 mole to mass. Now, to convert this to mass, remember, number of moles is equal to what? Okay, don't forget my mass. Look at it. All right, mass is equal to what? Number of moles. So mass is equal to what now? Number of moles. So that's 0.02 times molecular mass. So what would that be the molecular mass? Don't forget 36.5. So when you now do this, 0.02 times 36.5, you are going to get 0.73 gram. So it therefore means that in the question, we were provided with 0.73 gram of what? ACl. So when 10 gram of cacotyl is treated with 0.73 gram of ACl, please don't get lost. Follow me. Don't get lost. All right. Now, let us find, listen, in the question, we're given 10 gram of cacotyl treated with, we have resolved this 100 centimeter cube of ACl. We have resolved it. We got 0.73 gram in mass. So let us check, let us find the mass of ACl that will be required to react with 10 gram of cacotyl. Let us find the mass of ACl that will be required to react with what? 10 gram of cacotyl. So by the time we cross multiply, of course, you know what we're going to do now. We're going to get 100x is equal to 73 times 10. Then obviously we're going to divide by 100. Okay, so 100 cancel out 100. Therefore, when you do this, what are you going to get? 73 times 10, 730 divided by 100. All right, we got what? 7.3 gram. So it therefore means that 10 gram of cacotyl will require 7.3 gram of ACl. But in the question, when we resolve this, what mass of ACl were we given after resolving this mystery in the question, we're given what 0.73. Now between 7.3 and 0.73, which one is smaller? Is 0.73. All right, so 7.3 is bigger than 0.73. So they gave us ACL less than what is required. What 10 gram of calculating will require is 7.3 gram of ACL. But then in the question, after resolving this mystery, we got 0.73 gram of ACL. So therefore, it therefore means that was HCl, all right? Therefore means therefore ACL is the limiting reagent. ACL is what? The limiting reagent. All right, now we have discovered that ACL is the limiting reagent. Let us now find the mass of CO2. So we are not comparing this now. So it therefore means that the limiting reagent will determine what? The amount of CO2 that will be produced. So it therefore means now from this, what we have here is of this, we got what 73 grams. So it therefore means that 73 gram, all right, 73 gram of 73 gram of ACL we produce. Now 1 mole, I told you 1 mole of a substance is equivalent to what now? The mass of 1 mole of a substance is equivalent to the molecular mass of that substance. So this is 1 mole of carbon dioxide. So the mass of 1 mole of carbon dioxide will be equivalent to the molecular mass of carbon dioxide. What is the molecular mass of carbon dioxide? Carbon dioxide is CO2. Carbon is 12 plus oxygen is 16. So 16. This 2 is affecting 16 times 2. And when we do that, we're going to get what? 44. So 73 gram of ACL produces 44 gram of CO2. Are you with me? Sorry. So therefore, the limited amount we're given 0.73 gram. We produce how many gram of CO2? So by the time we cross multiply, of course, cross multiply and divide, we're going to arrive at x is equal to 44 times 0.73 all over what now? 73. Now let us put this in our calculator. We're going to get 44 times 0.73. That is this 32.12, then divided by 73. We're going to get 0.44 gram. All right, now we have not gotten to the end of this. All right, we have not gotten to the end. We want to get the molecules of CO2. Now what we got is the mass of CO2 produced. So now let us get the molecules of CO2 produced. Now this will take us to another formula in stoichiometry. The take us to another formula in stoichiometry, all right, which says that number of moles n is equal to number of particles, or you can say number of molecules, all over 6.02 times 10 raised to the power of what? 23. Now n, we can replace n with mass over molar mass, because n is also equal to mass all over molar mass. N is mass all over molar mass. So because we know the mass already and we know the molecular mass of CO2, we calculated it 44. So we are looking for the number of molecules. So number of molecules all over what? 6.02 times 10 raised to the power of 23. This guy is known as Avogadro's number. So what's the mass? 0.44 over what's the molecular mass? 44, equal to number of particles. You calculate x all over what? 6.02 times 10 raised to the power of 23. So by the time we cross multiply and divide, we are going to arrive at x is equal to 0.44 times 6.02 times 10 raised to the power of 23 all over 44. So put this into your calculator and let us go. So 0.44 times 6.02 times 10 raised to the power times 10 raised to the power of 23 give us this, then divide by 44. So our final answer is 6.02 times 10 raised to the power of 21 molecules. So this is our final answer to this question. So you can see that this question is it looks quite lengthy, but if you can understand the concept, it's actually very short and easy. You can jump step. So please do it to go over this video again and again so that you get the concept. All right. And if anything is not clear, please drop it in the comment section. All right, we have come to the end of today's video lesson. Don't forget to subscribe, like, and share this video to your friends. And I'll see you in the next lesson.